Today we are going to finally start actual geometry. This first lesson is just about 3 basic things that we're going to use the rest of the year: points, lines, and planes, okay, that make up pretty much everything in space. So a point, what do you guys, how would you define a point? I mean, there's not just one correct answer for this. How would you define a point, Kate?
Is where two lines.
Sure, yeah, that's a good definition. And we'll actually put that down at the bottom where it talks about intersecting lines. So where 2 lines meet. How would somebody else define a point? Any ideas? What was that? Okay, yeah. Similar to what Katie just said, where things intersect. But we can define it as even more general. It doesn't have to be where lines intersect. So a point we can just define as a location. Right? It has no length or width. In other words, it is 0-dimensional. Right? We could even say it has no length, width, or height. Right? But we think of those as the 3 dimensions: length, width, and height. So a point has none of those. No length, no width, no height. It is just a location in space. Right? Now, as far as notation, okay, we always use a capital letter to name a point. Okay, and we will use this for the rest of the year. Okay, whenever we see a coordinate point, we use a capital letter. Sometimes there'll already be capital letters there. Sometimes we will have to put in our own capital letters. But to name a point, we always use a capital letter. So here's an example. We just call that point A. And now, a lot of the time, we don't even write the word point. Okay, we'll just say A. Okay. Now, a line is made up of, how would we define that? Anybody know? 2 points. At least 2 points, right? A line is made up of at least 2 points. Because we can draw a line between any 2 points. Technically, though, we say that a line is made up of an infinite number of points. Okay? We can put as many points as we want on this line. Even just between x and y, we can say there's an infinite number of points on that line. Okay? So we can say a line is made up of an infinite number of points. But you're absolutely right that we could draw a line between any 2 points, okay? Which is the second bullet. Any 2 points on a line. Alright. So a line has no width or height. Right? In other words, it is 1 dimensional. Okay? We can say that a line has length, okay, but maybe not width or height. It has 1 dimension. Now, and as far as naming a line, we choose any 2 points on that line. Okay, so here we already have x and y as named points. So I can call this xy. Now, whenever I'm naming a line, I will actually draw a line over top. Okay, so that's the notation to name a line, using 2 points on the line and drawing a line over top. Now, there is another way if we see a lowercase script letter, we could also call this line and then whatever that lowercase script letter is. In this case, it's an N. Okay? So line N. The more traditional way is this first one, using two capital letters to name the line. Okay, but sometimes you will see lines named like this, line, and then a lowercase script letter. Now, two definitions that go along with this, okay, collinear and non-collinear. Okay? They sound like what they mean. Collinear means points that are on the same line, and non-collinear means points that are not on the same line. So, let's scroll down just a little bit. Notice the note underneath of non-collinear. It says must be at least 3 points. Why can't I have 2 points that are non-collinear? Right, what if I draw point Z down here? Couldn't I say that X and Z are non-collinear? Why not? Because they can still connect in a straight line, right? Any 2 points form a line. Even if it's not drawn there for you, you can draw a line between any 2 points. So we could still say that X and Z are collinear. We could not say that X, Y, and Z are all collinear. Right? There's no way to draw one line between all 3 of those points. So if we want to write an example here, X, Y, and Z are non-collinear. We draw Z off of that line. X and Y, though, are collinear. And we could even draw another point on here, call it A, and say that X, A, and Y are all collinear. And all of those are on the same line. We don't have to have 3 points to say they're collinear. We just have to have 2 to say they're collinear. But we have to have at least 3 to say they are non-collinear. Okay, so we could say that X, A, and Z are all collinear. So the final of these 3, a plane. The best way to, well, what do you guys think? What's the best way to describe a plane? Again, it's not just one correct answer. How would you describe a plane? Any ideas? So a plane, we're just going to describe it as a flat surface. And again, a plane is made up of an infinite number of points. Okay, on a flat surface, I could draw an infinite number of points. Now, the minimum number of points we say is 3. Any 3 points make up a plane. Okay, so here we've got K, J, and L on this plane. Even in that last example where we had X, Y, and Z, okay, I had a line drawn through X and Y and then Z off to the side. I could draw a plane between those 3 coordinate points. Now, this third bullet point is important. Okay? It says a plane extends infinitely in all directions. Right? So if you think about the table that you're sitting at, or the little desk, that flat surface is a plane. But in order to think about it geometrically, we have to think about it extending in all directions. Okay? It's not just that limited desk size. That plane, that surface, extends infinitely in all directions. Right? So even though Rachel's desk stops here, I could say a point on the plane is out here. Right? That plane extends infinitely in all directions. To name a plane, we use any 3 non-collinear points. Okay, this non-collinear points part is important to name a plane. If I choose 3 collinear points, all I've done is name a line. Right? In order to name a plane, I have to choose 3 points that are not on the same line. So, in this example, I could call this plane KJL. There isn't really a symbol. We don't really write plane. I would just call this KJL. Right. There is a second way, okay, using an uppercase script letter. So to name a line, we can use a lowercase script letter. To name a plane, we can use an uppercase script letter. So here, they have an uppercase script P. So that distinction is important. We're not saying this is point P, right? That's a script letter or a cursive letter. So we would say that another way to name this would be plane P, right? Cursive or a script P. So similarly to lines, right, we could say that points are coplanar or non-coplanar. Coplanar points are points that do lie on the same plane. Non-coplanar points are points that do not lie on the same plane. So again, we've got a note, must be at least 4 points. Why do we say it has to be at least 4 points? For them to be non-coplanar. Why must there be at least 4 points? Summer? Yeah, so we can make a plane through any 3 points. Right? We can make a plane through any 3 points. And that's kind of tough to visualize. Right? But let's say I put 2 points on the board, and then I've got a third point out here. Right? I could draw a plane through those 3 points. Right? Any 3 points in space, I can draw a plane through. But if I add a 4th point, right, say here are my 3 points, and then the eraser is a 4th point, there's no way for me to draw one flat surface through all 4 of those points. Okay? There's always a way to draw a surface through 3 points, but not always through 4 points. So that's why we say that points, the non-coplanar points, we have to include at least 4 of them. And so it's impossible to draw an example of that on your paper, right? Because your paper is a plane, it's a 2-dimensional object. So you have to think about, well, here are 3 coordinate points, and then if I add a 4th point off of the paper, those would be non-coplanar. Okay. The last thing on here, right? Intersections. The first one, as Katie already told us, right? 2 lines intersect in a point. 2 one-dimensional objects intersect at a 0-dimensional object. 2 planes then would intersect at a what? A line. Right? 2 two-dimensional objects would intersect at a one-dimensional object. Is it possible for 2 planes to not intersect? Or would every set of planes intersect at some point? Yeah, they're parallel. Okay? Then they'll never intersect. The floor and the ceiling. Right? If we extend those forever in all directions, theoretically they wouldn't intersect. Right? I mean, I guess, if the ceiling's off 1/10 of a degree, they would eventually. But theoretically, the ceiling and the floor are parallel. Theoretically, the front wall and the back wall are parallel. Right? If we extend those forever, they would never intersect. Right? So the idea of parallel, we've worked with parallel lines before, but that idea extends to planes as well. Right? And we'll take a look at that a lot more later this year. So let's flip your paper over and try some of this stuff. Right? So for some of these, there are a lot more than one correct answer. For some of them, there are only one correct answer. Right? But let's go through one of these together, and then I'll have you guys work together on the next three. All right? So, number one, we're looking at this diagram over here. We've got a bunch of points, a few lines. The first one says name 4 collinear points. What's collinear?
Points on the same line.
Points on the same line. So we want 4 points on the same line. What do we got? Where is it? Wait, say it again. HNKI, yeah. So to write that, I'm just going to list those capital letters. Right? That's how I name points. So I'm going to say HNKI. B, a line that contains point M. There's more than one correct way to do this. Okay?
M and O.
So, how do we name a line? How many points do we choose on that line? 2, right? We only choose 2 points. Okay? 3 points names a plane. Right? So, to name a line, we only want to use 2 points. So, we could choose any of the 2 points on that line. Right? We could call it MN, or we could call it NO, or we could call it MO. Right? There's even another way. How else could we do it? Yeah, we've got a lowercase script letter to name it as well. Right? So we could even call it line P. Now, when you're doing these on your own, you don't have to write out all of the possibilities, right? You just have to choose one, okay? But for now, I'm going to show you all of the possibilities, okay? So we named this line 4 different ways. Okay? How about C, a line that contains both points H and K? Again, more than one correct answer here. Okay? Line R, right? Using that lowercase script R. How else? Okay.
Line HK.
HK. Okay. Pretty straightforward. Using the 2 points they actually named. How else? Roxy. KI, you said? Yeah, that would work. Right? I mean, HN, NK, right? There's a whole bunch of possibilities. I'm not going to write them all out. But there are a lot of answers. How about another name for line Q? JK. KL or JL, right? Lots of possibilities here. How about the intersection of lines P and R? Okay. Lines P and R intersect at point N. Questions? All right, then let's take a few minutes here. You guys work together and try the next 3. Alright, take a look up here. Got some answers. Now again, there are, for a lot of these, there's more than one correct answer. Okay, so like for A, a line containing point F. I said line J, but we could have also said DF or DE or EF. Right? Lots of correct answers. So just because this is the one answer that's up here doesn't mean that yours is incorrect. So take a look at these answers up here. And ask any question. If you want to know if yours is correct, or if you have a different thought on some of these. What do you think? I think a couple, I'm not going to go through all these, but a couple that I want to highlight. 2E, the intersection of plane M and line K. Right, so if I've got a plane and a line going through it, right, so a plane and a line going through it, that's going to intersect at a point. Right? We didn't talk about planes and lines together. We just said two lines intersect at a point, two planes intersect at a line. But if we're talking about a plane and a line, that would also be just at a single point. Right? So here, that answer is point E. In number 3, a couple of the trickier ones. I guess for C, visualizing where two planes intersect. So plane R is this bottom plane, right? And plane Z, VY is this kind of backside face of this pyramid. So those two planes intersect at this line right here, right? Line VY. Then the next question is how many planes appear in the figure, right? Or how many surfaces do we see? Well, it kind of looks like 6, right? If we count 1, 2, and then the 4 faces or the 4 sides of the pyramid, right? But I think we're assuming that this bottom of the pyramid is on the same plane as plane R, right? So that's where we get 5 planes for this one. And then how many of those 5 planes contain point W? Well, the bottom, right? And then the front face and this face off to the right. So that would be 3 of the planes that we see. Any other questions on 2 and 3 here? All right, then take a look at 4. So,
Number 3, it says 3 pictures. How do we do that?
Yeah.
X, Y, like I'm not on that, but isn't that like all the same?
X, Y, and W? So coplanar just means on the same plane. So yeah, we're X, Y, and W would all be on this same plane. They wouldn't be on the same line. They wouldn't be collinear.
I was looking at coplanar and
Wait, say that again?
well, I just looked at like 3 coplanars. How do you say that? And then the definition on the front was like on the same line.
No, points that lie on the same plane. Oh, points that line on the same plane. There is a typo. I should say points that lie on the same plane. Where is it? Yeah, so this is just any 3 points that are on the same plane. So we could have said Z, V, and Y, or Z, Y, and X, right? Or V, W, and X. Yeah, so of those named points, no 3 of them are collinear. Right? Yeah. What other questions do we have here? We do all right on number 4? Amber? For B here? I-F-E. Alright, so we just, for B here, another name for plane Q, we just needed to choose 3 non-collinear points. So we could not have chosen F, E, and G. Right? I could not have said plane F, E, G, because those 3 points are on the same line. And I need to choose 3 points that are not on the same line to name a plane. Okay? Then for C, are points D and E coplanar or collinear? Technically, it would be both, right? I mean, collinear is more specific, right? If 2 points are on the same line, well, then we could definitely draw a plane between them, right? I could absolutely draw a surface between points D and E, right? But collinear is more specific. And how many times do the two planes intersect? Well, it appears that they're parallel. Right? It appears that they're just going on forever, right up and down next to each other. So it looks like 0 times. Any questions?